رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope all of you are doing well. Today we are going to continue our topic 3.2, and in today's lecture we will discuss about the force and the momentum. Consider a body of mass m which is initially moving with the velocity vi. After some time, if we apply the force onto the object which is moving in the direction of its initial velocity, then we can see that by the applying force, acceleration will be produced. And this acceleration will change the velocity of the body from initial velocity to the final velocity, which is Vf. So as a result, when the force is applied, it changes its velocity. And also, we know that the momentum is the product of mass times velocity. So if the initial momentum of the body is mvi, the final momentum becomes mvf. From this situation, we can see that by applying the force, not only acceleration is produced, velocity changes, but also there is the change in momentum from its initial value to the final value. So we can find out the change in momentum as the final momentum minus initial momentum, while the final momentum can be written as Pf minus initial momentum, which is Pi, while the final momentum is mvf minus initial momentum, which is mvi. So as a result, not only there is the change in velocity, but also the momentum will be changed when we apply the force on the moving body. If we want to find out the rate of change in momentum, so we divide this term by t. So the rate of change in momentum will be given as Pf minus Pi divided by t equals mvf minus mvi divided by t. And if we take mass common from this term, we will get mvf minus vi over t. Now dear students, can you tell me what this term equals to, vf minus vi over t? Isn't it the change in velocity, the rate of change of velocity? Yes, you are right. So vf minus vi over t is the rate of change of velocity. So as a result, the rate of change of velocity equals to the acceleration produced by the force F. So we can equate this equation Pf minus Pi over t equals to ma, where a is the rate of change of acceleration produced by the force F. Now dear students, did you get any idea from this equation ma? Isn't it the Newton's second law of motion? Yes, it is. So according to the Newton's second law of motion, force applied on the body equals to mass time acceleration. So we can equate the above equation as Pf minus Pi over t is equals to F. So the rate of change of momentum can be written as the applied force. Or we can say that whenever we apply a force on a body, it produces the rate of change of momentum in it. We can also define the Newton's second law of motion in terms of the momentum as when a force acts on a body, it produces acceleration in the body and will be equal to the rate of change of momentum of the body. And according to the Newton's second law of motion, when a net force acts on a body, it produces acceleration in it in the direction of the net force, and the magnitude of this acceleration is directly proportional to the net force acting on the body and inversely proportional to its mass. We can also define the Newton's second law of motion in terms of momentum as the rate of change of momentum. So force F is equals to the rate of change of momentum, or the change in momentum is the product of applied force into time. So from this equation, we can write down another unit for the momentum, which will be equals to Newton second. The one unit from the previous equation of momentum, which was mass time velocity, we get the unit kilogram meters per second, and this kilogram meters per second also equals to Newton second. Newton is a unit for force, second is a unit for time. So we get 2 units for the momentum. That's all for today from the topic. I hope all of you get the topic, and now we will solve one of the example from your book, which is example 3.6. Example is a body of mass 5 kg is moving with a velocity of 10 meters per second. Find the force required to stop it in 2 seconds. First of all, we will write down the data from the statement. Mass of the body is given, which is 5 kg. It is initially moving with a velocity of 10 meters per second. So the initial velocity will be 10 meters per second, and we need to require to stop the object. When the object is not moving, then the velocity will be 0. So the final velocity of the body will be 0. And how much time is required to stop the object? 2 seconds it will take to stop. And we have to find out the amount of force which is required to stop this body, which was initially moving with the 10 meters per second, in 2 seconds. So the thing which we need to find out is the force that is required to stop the body in 2 seconds. So we can use the formula of the rate of change in momentum. While the formula is F is equals to PF minus PI over T, where PF and PI are initial and final momentum and T is the time. Now moving towards the solution, first of all we have to find out the initial and final momentum. Initial momentum equals to mvi, mass is 5 kg, initial velocity is 10 meters per second, so initial momentum will equals to 50 Newton second. While the final momentum is equals to mvf, mass is 5 kg but the final velocity is 0, due to which the final momentum also equals to 0 Newton second. Now substituting these value of momentum in the equation of force, we get 0 Newton, which was the final momentum, minus initial momentum, which is 50 Newton second, divided by the time, which is 2 seconds. So the force required to stop the body will be equals to 25 Newton. This negative sign shows the applied force must be act in the opposite direction to the moving body to stop it. Thus, the magnitude of the force will be 25 Newton, which is required to stop the body. That's all for today. I hope all of you enjoyed today's lecture. If you have any kind of queries, you can write down your question in the comment section below. See you in the next video with a new topic. Till then, take care and Allah Hafiz.